Okay, today we are going to be working on Module 4, Lesson 2. Our objective for today is that we're going to be able to interpret a fraction as a division problem. So we're going to start out with 2 divided by 2. So when we are writing a division as a fraction, we are just going to think of it. We're going to take our first number. It's going to be equal to the same. Our first number is what becomes our numerator, and our bottom number is what becomes, or the second number, becomes the denominator. So 2 divided by 2 is the same as 2 over 2, or 2 halves, or you can say 2 divided by 2 as well, which in the end still equals one whole thing. So that is what that would look like. If I wrote the problem 1 divided by 2, again, that would equal, I'm going to take my first number, that's going to be my numerator. The second number is going to be the denominator. So 1 divided by 2 is the same fraction as 1 half. Again, so you can see the first number becomes our numerator, and the second number becomes the denominator. We can do another one, and we would say 2 divided by 3 is the same as 2/3. Okay, so these are fractions that I don't even necessarily have to go into simplest terms or divide further out. So let's do one that might be a little bit more. So what if I did 3 divided by 2? That would equal, again, this first number becomes our numerator. The second number becomes our denominator, right? So I have 3 halves. Now this is called an improper fraction, if you remember, because my numerator is larger than my denominator. So we would still break this down into saying how many times can 2 go into 3? Well, it can go to 1 whole time. And then how many would I have left over out of that 3? I would have 1 left over, and my denominator stays the same. So it's also the same as 1 and 1/2. You can also think of this as if we were to draw a picture that would represent it. 3, I could draw 3 whole boxes. 3 whole boxes. And it means I'm going to cut them into halves. So I cut it into halves, halves, and halves, which would give me 6 halves, right? 1, 2, 3, 4, 5, 6. So you could rewrite that as this is equaling 6 halves divided by the 2, which would be 3 halves when you see it pictorially. So again, just remember that our first number becomes our numerator and the second number becomes the denominator. And then if it becomes an improper fraction, you need to divide it out into a mixed number. If it were to become a number we can still divide out, we would find our GCF and divide out. Okay, so now that we took our notes in Lesson 2, we're now going to practice what we just learned in Lesson 2 about turning our division into a fraction, and we're going to fill out this chart. So we're going to have our division expression. We're going to have our unit form, so with the numbers and words, and we're going to have the improper fraction, and then we're going to turn it into mixed numbers, and then we're going to show how you can do it with standard algorithms. So we're going to show how all of these things are related. So this is the example. Here is the division. They had 5 divided by 4. Okay? For me, sometimes I like to already turn it into the improper fraction first. So I say, we remember the first number goes on top. The second number is our denominator, so 5/4. And then I like to turn it into a mixed number, which becomes 1 and 1/4. And then when we think about that, right, we know that if we take 5 and we divide each into 4 sections, we're going to come up with 24. So this number, I want you to think, is really, if you take these two numbers together, multiply them, you're going to get that number. So we get 20/4 divided by 4 is 5/4, or here is our improper fraction. And then here is them showing it again as standard algorithm division. So let's try a few together. So here we have 3 divided by 2. As my improper fraction, I'm going to write 3 divided by 2, or 3 halves. They already turned it into a mixed number for us. We know 2 can go into 3 one time, and 1 is left over, and 2 stays as our denominator. Well, I have to think 3 times 2 would make 6 halves, right? If I have 6 halves and I divide those 6 halves into 2 groups, we're going to have 3 halves in each group. Now, when I come over here to do my division, I'm going to say 2 divided by 3. Well, how many times can 2 go into 3? It can go 1 time. 1 times 2 is 2. I subtract. 3 minus 2 is 1. I have nothing else to bring down. This becomes my remainder. And now my remainder comes up here, 1. And the outside becomes my fraction. So 1 and 1/2. And then I can check it by saying 2 times 1 and 1/2 is the same as adding 1 and 1/2 plus 1 and 1/2. So all these are the same. So 1 plus 1 is 2, and then half plus half is 1, which gives me 3. And it's back to that answer right there. So we should be able to go right straight back to that. So now we're going to try this again down here, right? So now they haven't given us, they have 24/4 divided by 4 equals 6/4. So we're dividing by 4. So that means over here, we're dividing by 4. And we're going to take 6 of them and divide it by 4. So that means I have 6 divided by 4. How many times can 4 go into 6? 1 whole time. How many is left over? 2/4, which then also I can reduce down to 1 and 1/2. Then over here in the standard algorithm, they already did. 4 into 6 can go 1 time. 1 times 4 is 4. Subtract, I get 2. If I bring 2/4, but remember, I can divide a 2 out of the 2 and the 4. So this is really 1 and 1/2. And then I would, to check it, I would do 4 times 1 and 1/2. Okay, I'll do one more for you. So 5 divided by 2 is going to be 10 halves. Divided by 2 equals 5 halves. So we have 5 halves, which would be 2 and 1/2. So we're going to be 2 into 5. Can go 2 times. Times 4, 1, and I'm left with 1 and 1/2.